Hello intellectuals, I hope everyone is fine. Welcome back to our today's tutorial. We are looking at cubic function. Now this is part 2. In case you have not watched the part 1 of the cubic function, you will see a pop-up on your right hand corner. Make sure you click on that, you watch it, then you come to this video. If you are new to this channel, you make sure you subscribe and hit the notification bell so that you become one of those first people to receive the notification when we post a new video. We got a question from 2018 paper 2 GCE, that is question 12b. That is a question we are handling today. We talked about how to plot. Now we want to know how to handle a question where the cubic or the graph of polynomial has already been plotted for us. Now we are being asked to find the equations and also to find the gradient as well as the area for the given portion. So we have this question is saying the diagram below shows the graph of, so this is the equation that is bounding this graph, that is y equals to x cubed plus x squared minus 12x, and this is the graph given here. The questions we have under this question, we have used the graph to solve the equations. Now the first equation we are solving is this one here, x cubed plus x squared minus 12x equals to 0. If you remember in our first video, we said whenever you are solving equations, the first thing that should come in your mind is we are comparing. The equation we are solving, we are comparing it to the original equation. I hope you are getting me right there. So for me to begin to solve, I'll first of all write down my original equation. So I'll write it down. So this is my original equation. Then I'm going to bring down the equation I'm trying to solve. I'll bring it below my original equation here. What is the next step after you're done like that? Now remember, this question, it has already been plotted, meaning it's in your question paper. So you don't write answers on your graph paper in this way. If it has already been plotted for you, your answers are supposed to go in your answer booklet. You just indicate the question number. I hope we are getting each other. Okay, so in this case, what do you do? If you remember in our first video, we said, first of all, check your original equation. How many terms do you have on your original equation? In this case, we have 1, 2, 3. These 3 terms, they should also be there on my equation I'm solving. None of these terms should miss. Okay, so come back to the equation. We have x cubed, we have x squared, we have negative 12x. So there's nothing which is missing. What is our next step? Our next step now is to start cancelling out what is similar. So the x cubed and the x cubed, they are similar. They are similar, we cancel those. The x squared, we cancel. Negative 12x and negative 12x, we cancel them. What remains? You can see on the original equation, what is remaining is y. On the equation I'm solving, what is remaining is 0. So I'm going to equate y equals to what has remained on the equation I am solving. So in this case, it is y equal to 0. This is not the answer, but y equals to 0 will help me to find now the answer. So I'll go back to my graph. I'm supposed to draw a line y equals to 0. Now in this case, because y equals to 0, it is just the x-axis. So this axis here, the x-axis, is the one which is y equal to 0. So there is no need for you to start drawing a line already there, because you have drawn the x-axis already. What is the thing you're going to do now? So you will look at where this line is intersecting. Where is it cutting your curve? In this case, my line is cutting my curve on 3 points. There is this point here. This line is cutting the curve here. It is also cutting it here, and at the same time here. So it means we have 3 solutions for that question. So you can see where I'm putting the dots. So it is intersecting here. It is also intersecting here. At the same time, it is also intersecting there. So in this case, as you can see, let me just zoom in a bit. So as you can see, this is a point of intersection here also, and also here. So those are the points of intersections, and we are going to pick answers. So from here, where your line is intersecting with a curve, you only pick the x value. We don't get the y value. The solutions are the x values. So at this point here, what is my x value here? This is -4. If you look at here, this is 0. Here, +3. Good. So those are our answers. So we have x equals to -4, x equals to 0, x equals to 3. We have answered. That is the 2 marks. It means we have gotten the 2 marks. Do not start inserting these values in your equation and then you start solving. No. They are saying use the graph. So we have used the graph to find the solution. That is all. We go to the next question. The next question is saying, again we are using the graph now. We are solving again another equation. So the same thing, because we are solving an equation, first of all, the original equation has to come down. So I'm going to jot down the original equation. Then the next step is to bring down the equation I'm solving now. So this equation we are solving here, it has to come down below my original, like that. So now, since we have these 2 equations, again at the same time, I'll check. I have 3 terms. Are these 3 terms on the original? Are they reflecting on the equation I'm solving? Okay, so in this case, yes, they are. So we go straight into cancelling then. So we cancel out what is similar, like that. Okay, what has remained there? On my original equation, what has remained is y. And then on the equation I'm solving, what has remained is x plus 10. In this case, we have y equals to x plus 10. This one here cannot be plotted directly. You cannot plot this one. So what do you do then? You are going to be drawing a table of value that will help us to come up with a line for this equation. What we want is a line. Okay, so that line can only come about if we draw a table and then we insert some values, we come up with some coordinates to draw up that line. Where that line will cut the curve, that is our solution. Okay, so let us go straight into drawing the table. So you are going to be drawing the table with the a 6 slots table. Okay, so you have 2 rows, of course, with the 3 columns. Now in this case, in the first 2 boxes, you are going to be putting x and y. Please do not confuse cubic function, or do not confuse the graph of polynomial with linear programming. Under linear programming, we say put zeros in here. But for this one, we are not going to be putting zeros under graph of polynomial. We'll come back to the Cartesian. We are going to be picking values within our curve. So you can pick, for me, I'm going to pick -3 and a +2. Okay, those are the values I'm going to pick. You pick only the x values. In the graph of polynomial, we pick one value x, another one value is for y. But in this case, we pick the x values only. So I've picked a negative and a positive value, so that I can have a wide range and I'll be able to connect a straight line there. Okay, so what do I do with these values? I'm supposed to find now the y values. After getting my x values from the Cartesian, I'm now going to find the y values using what? Using this equation I have here, because that is the equation I'm trying to plot a line for. So in this case, we have y equals to x plus 10. For the first slot, instead of x, I'm going to put what? I'll substitute with a negative 3. So I'll say negative 3 plus 10. Okay, so negative 3 plus 10. What's the answer there? Different signs. We have to subtract the smaller number from the bigger number. Then we maintain the sign from the bigger number. So in this case, our bigger number is 10, so we maintain the positive. When we subtract a 3 from 10, we have a what? Correct, we have a 7. So it means our first answer here is a 7. Then we go straight again to another one. So we have y. Now this time around we are putting a 2. So 2 plus 10. Now 2 plus 10, what's the answer there? Correct, it's a 12. So the last slot there, the answer is 12. We have those. It means we have coordinates now we can plot. Okay, so the first coordinates are negative 3, 7. That is our first coordinate. The second coordinate is 2, 12. That is our second coordinate. So we're going to plot these 2 points on the Cartesian. Negative 3, 7. Coming back to our Cartesian good, this is what we're going to do. So if you look at the scale here, if you remember nicely what I explained back then, we said, how do you find the unit for a smaller box? We said the units you are representing, divide them with the number of lines in that box. So in my y-axis, in my x-axis, if I want to know the smaller box, what it represents, what I'm going to do is I'll divide. You can see our scale here. It's 1 unit. Okay, so 1 unit is represented in the 2 centimeter box. 2 centimeter box is carrying 10 lines. So I'll say 1 divided by 10. So if I divide this one, I'll have what? Correct, 0.1. So this simply means that smaller line, that is 0.1. So in this case, we are saying, now these are direct ones. We don't have estimate, we don't have decimal fractions. We have exact values. So negative 3 is here, 7. In the y-axis, in the 2 centimeter box, we are representing 10. So if we say 10 divided by 10, what answer are we going to get? Correct, 1. So each line in the y-axis, each smaller line is 1. I hope we are getting each other there. Alright, so in this case, for you to find, so negative 3 in the x-axis, then 7 in the y. I'm going to go 1, 2, 3, 4, 5, 6. So 7 is here, and we've put a dot there. So why am I indicating this? Because at the end, I'll have to draw a line. Alright, I have to draw a line. That is the one that will give us the solutions. Then positive 2, 12. So the 2 in the x-axis, the 12 is from 10, 11, 12 is right here. I hope we are following each other there. So amongst these 2 points now, you are going to connect these 2 points. This point, you connect it to this point. And you make sure that your line you are drawing, it should cut your curve. Okay, so let us draw up the line. I'm sure you are able to see the yellow line there. Okay, so that is our line there, as you can see. So we've drawn a line. You also do the same, because this line is the one that will give us the solutions now. Okay, so let us begin to find the solutions. Now, what do? Where this yellow line you are seeing here, where it is cutting the the curve, that is where our solutions are. Remember, we are only getting the x values. So from there you draw dotted lines. On that point you draw dotted lines, and on that point you draw dotted lines. So that is what you do. You can see the dotted lines here, dotted lines here. So where the line is cutting the curve, it is cutting it on 3 points. So here and there. So if you look at here, because we have said this is representing 0.1, so from 3 here, this is negative 3.1, 2, 3, 4, 5, 6, 7. So x on this part here, it is x is equal to negative 3.7. Then here this is 1, 2, 3, 4, 5, 6, 7. So negative 0.7. Then here 3.1, 2, 3, 4. So 3.4. Those are our solutions. So as you can see, those are our solutions. That is finding or solving the equations using the graph. Now let us go into finding now the gradient as well as the area bounded by the curve. We are done with the first part. Now we are handling these other parts now. So finding the gradient, in the first tutorial where we had cubic function, we learned on how to find the gradient using integration. And I promised to say we are going to use both ways. So this time around, I'm going to use how to find using the coordinate geometry. So I'm going to teach you on how to find the gradient using a different formula. Of course, 2 methods, they are correct. You can use calculus or you can use this method. They are still correct. Okay, so let us begin. Calculate an estimate of a gradient of the curve at the point where x is equal to negative 3. Okay, so in this case, once you are given such, you go back. When you are calculating gradient that you are asked to find in this case, it will be one of the points you have already plotted on the Cartesian. Of course, this one is not as we plotted. It's already done for us, but still it is one of the points where on the curve. So we'll zoom in a little bit. So in this case, we'll go where there is negative 3. So negative 3 in the x-axis is here. I'm going to follow the line for negative 3 up to the curve. Okay, up to the curve. So this is where my point is. And that is the point where I'm supposed to calculate the gradient for this curve. So what do you do? This second method, you're supposed to draw now a line, a tangent. When we say a tangent, it should only touch one point on this curve. If it touches 2 points, that is not a tangent, it's a secant. So make sure it touches just 1 point there. So I'm going to draw up a line, okay, like so. So that is our tangent line there. Okay, so that line is only touching 1 point. Now, what do you do next? Okay, what do you do next? So the next step there is to allocate. So we are going to identify, after we are done with that, we are going to, since we have a first point, so in this case, if you look at what we have here, you can see that our first point we have is negative 3. Okay, negative 3 comma what? So my y-axis, my y value in this case will be 18. Okay, so my y value in this case will be what? 18. You can see here where it's going. So my y value in this case is 18. So comma 18. Okay, so this second method we are using, it will require us to use the gradient formula, where we say change in y over change in x. So that is why we are getting those coordinates. Now, what is the follow-up step? The next thing you're going to do is to pick another point within your tangent line. Don't get a point in the curve. The second point you're going to get, it should be within your tangent. So just make sure that as you are picking your point, it should be closer to your point of gradient. So in this case for me, I'm picking a point which is just right here, as you can see, this part here. So that is where I'm picking my point. So from here, I'm going to pick my x value. Okay, I'm going to pick my x value. At the same time, I'm going to pick my y value. So dotted lines like that. So in this case, you can see my x value here. Remember the scale for x-axis. So this is negative 2.1, 2, 3, 4, 5. So my x value is negative 2.5, comma. So these are the second coordinates. Then my y value here is 21, 2, 3. So this is 23, my y value here. So these are the 2 points we are going to use to calculate a gradient for this point. Okay. So let us begin our so we had those points. So we have negative 3, 18. We also have negative 2, negative 2.5, 23. So those are our values that we are going to use. So these are the values that we are going to use. Now, remember the formula for gradient. Okay, remember the formula for gradient? Change in y over change in x. So over these values, on these values, we have x1, y1, x2 over y2. So as you can see now, we have x1, y1, x2, y2. So we are going to substitute them on the formula. So our y2 in this case is 23, so we'll put a 23 there. Then our y1 is 18, so minus 18. Our x2 we are putting is negative 2.5, we are putting negative 2.5 here, minus our x1 is negative 3. Now notice what I've done. I've said minus, then I've opened the brackets, I've put the negative 3 inside the brackets. Normally people make mistakes. They forget to say the value I'm inserting there has a negative. At the same time, there is already a negative there. So you make sure you separate them so that you don't make mistakes. Okay. 23 minus 18, what's the answer? Correct. Okay, so we have a 5. Then here, in this case, we had something like, so the negative and the negative multiplying these two will give us a positive. So below here we have negative 2.5 plus 3 now. The 3 has changed into a positive. In this case, we continue. 23 minus 18, we have a 5. Then negative 2.5 plus 3, we have 0.5. From here, what do? Should we leave it like this? No. Let us divide. So since this is your paper 2, if you can't manage to divide it directly, you can use a calculator, no problem. So if you divide a 5 by a 0.5, you're going to get a 10. So that means that is your gradient. So that means that is your gradient at the curve. So that means m is equal to 10. This is the gradient of a curve at the point where x is equal to negative 3. Let us proceed. Question number Roman numeral 2b. Calculate an estimate of the area bounded by the curve. Then we have x negative 3, x equal to negative 1, then y equals to negative 10. In this case, when you are finding area, it's very important that you make those boundaries. So you've been given limitations. You don't just find the area anyhow. You have limitations these are acting like a fence. Okay, if you have a plot or something and there is a fence, you cannot go beyond that. So let us create our fences for those. So x equals to -3. Okay, so you can see the line, I've drawn the blue line there. So this is my x equals to -3. You do the same, you draw that line because you want to indicate the portion. Then we have x equals to -1. This is x equals to -1. I've drawn a blue line there up to the curve only. Then y equals to -10. So y values are going like this. So y equals to -10 is right here. You can see a blue line there. So this is the portion that we have. And this portion, if you look at it, if you remember in our first video, we said we are supposed to calculate the area using shapes. So here we can just create two shapes. And those shapes are trapeziums if you look at this nicely. So let me just create this one here. So this is a trapezium. This is another trapezium, as you can see there. So we have we have two trapeziums. Let me just shade them a bit. I think you can see the shapes here nicely. So these are the shapes that we are going to use. This is the first shape. Let me just shade it quickly like that. So as you can see, those are the shapes that we are going to use to find the area. So we have two trapeziums in this case. So the first trapezium here, we're going to find the area of this trapezium, and then we're going to add plus the area of this another trapezium. So in this case, this is our A. Then this other side, this is our B. This is our height. Same applies with this. This is our H. Then this is our B, same with this, and then this is our A. So if you look at, if I want to find the length for this height, I'll look at in which side am I moving. I'm moving in the x-axis. So in the x-axis, this is 2 centimeters. So from here to here, this is just 1. Same applies from here to here, this is just 1. So this height here is 1. The height here is also 1. But what about the A on this side? So the A here, I'm going in the y-axis. Remember, in the y-axis, each smaller box, 1. So 1. So from here to here, this is 10. From here to here, this is another 10. Then 10. So 20, 21, 22 up to there. So we have A equals to 22. Then the B, this is 10. 20, then 30. So our B in this case, for this first trapezium and also the second trapezium, it is 30. Then the A for this other trapezium, this is 10, 20, 21, 22, 23, 24, 25, 26, 27, 28. So we have a 28 in this case. Okay, so those are the values that we are going to use to calculate the area of this portion. Okay, so let us begin. That is the formula for area of a trapezium. Okay, so we are going to start. So we have the first slot, so we have indicated for this left side portion, 28. We have a 28 plus 30, then plus 1. Then we have the other portion for the other trapezium there. So 28 plus 30, what is the answer? Okay, we have 58, good. Then what is 22 plus 30? Correct. So here if we multiply the 1 times the 1 here, we're still going to have this 1 here, no change. So we still have 1 over 2, then times 58. Same applies here. If we multiply the 1 with the 1 on top there, no changes, we still have 1 over 2 there. Okay. Then there we have a 52, adding 22 plus 30 there. Then what do? We divide the 2 into 58. How many times? Correct. That is 29. Then the 2 into 52, that is 26. Then you add, what is 29 plus 56? So the answer is 55. Now, this is area, and we don't know what units are being represented here, either kilometers, centimeters, millimeters. So you don't write anything like that. You just write words to say square units. That's all. It means you are done for this question. So thank you very much, guys. If this video helped you and you'd want it to help others also, make sure you share with your friends. And if you've not considered subscribing to our channel, make sure you subscribe and support my channel. So thank you very much. See you next time.